All right, so looking at this one, number 3 is where we're at. Nothing factors. You cannot split the numerator into x plus 1, x minus 1. Why not? Because it's plus. It would need to be subtraction for it to be difference of squares. So nothing cancels. Cool. No work. Do domain first. Who is your troublemaker that is not invited to the domain party? -2. We're going to leave out -2. -2 is causing problems. Kick him out.
So if it's the denominator, is it always the total?
Yes, denominator equals 0. You can't divide by 0.
Oh, so that's going to be a whole.
Well, that's the next question. Is the -2 the whole or the vertical asymptote? Those are the two things. Good. Why is there not a whole? Yeah, it doesn't cancel out. So x equals -2 is your vertical asymptote. And again, I would go ahead and put that on the graph the second you get it, so that it's one thing at a time. Then I would do the other asymptote. You want to get the asymptotes first. You compare the powers. So do you see how this one's 2 and this one's 1? If the numerator is bigger, you have a slant asymptote. Now you're going to have to extra listen because this is the one new thing that you didn't learn last year. It's still going to be y equals, but instead of just a number, do you remember y equals mx plus b? It's going to be that. And the way that you get it is with your synthetic division. So look over here. Who did we say our troublemaker was? -2 goes in the little box. Is your countdown in order?
No.
No. You have 1x squared and then 0 x's and then 1. Now, the remainder will not necessarily be 0. I want you to go ahead and do the synthetic division. Bring down the 1, and then off you go. Multiply, add, multiply, add. You guys nailed this on your test. You're going to be just fine. One -2, 5, or can I get confirmation on that? We got, okay. Now listen. Are you listening? We don't use the remainders because if you're going out to infinity or -infinity, and this is another thing where our brains really can't compute infinity, so don't try too hard. But the remainder is so tiny as to be insignificant. It is like a teardrop in the Pacific Ocean. Do you get what I'm saying? Like it doesn't matter. We just get rid of it. Okay. So this is going to be y equals 1x minus 2. So those are your coefficients. So it's y equals 1x minus 2. Now you have to remember how to graph y equals mx plus b. You start at the -2, and then your slope is 1. So up 1 over 1. This is literally what we're doing in Algebra 1 right now. Watch me do it first, and here I'll zoom in. So you're going to start at -2. Do you see how that's right there? And then you go up 1 over 1. But just instead of points, it's an asymptote. So you just want to like make it a dashed line. No, it's a slant asymptote. Yep. Yeah, exactly. It looks cute. You'll like it. All right. So everything we have on there is invisible. It would sure be nice if we had some points. X-intercepts. You would take this whole equation and set it equal to 0. And then you start working that out. Hold on. What would be your first step? You would multiply over the x plus 2, but that would just give you 0. So you have x squared plus 1 equals 0. And then what? Keep solving. Like you just got to keep going. -1. Okay, now real quick, because you did this on your last test. When you square root -1, it would be plus and minus I. If it is imaginary, can I put it on the actual graph? No, so there just aren't any. If you get something imaginary, it's just none. We're saying there's none real ones. If any of you go into a degree in mathematics, there is actually an imaginary plane. You can Google that if you want, and things can get graphed on it. And there's all kinds of cool looking stuff with like fractals and things on it. So anyway, if you feel like Googling that, you can do that. All right, y-intercept. Oh, hold on. We're gonna plug in 0. So look, 0 squared, 0 plus 1, 1. So the numerator's 1. And then down here, 0 plus 2 is 2. So 1/2, which would be right here. Now, that's all we've got. Your graph has to coast along the asymptotes, though, and it has to go through this point. So it's going to do something like this up here, and then you're going to get the other arm of the graph down here. So it really looks like an hourglass. Isn't that cute? That's cute. It's cool, guys. This is neat. It's neat. It's cool. This is cool, guys. And you graphed that without a calculator. I feel like math, and I had this conversation with a student one time. Math is one of the only subjects that gives you that feeling of satisfaction. Like, oh, I did that. Hey, look at that. Graph that without a calculator? Shaking your head. It's cool, guys. It's cool. Get on board. All right. And then the last thing we have is the end behavior. Now, this one's not going to be a number because it's not leveling off somewhere. It's either going up or down. I had a student one year say to me, Miss Cole, there are arrows everywhere. How do I know what to look at? And I was like, fair. So I started teaching it like this. It's called end behavior, not middle behavior. So if you take your hand and cover up the middle of the graph, these are the two ends you want to look at because there are arrows everywhere. All right. So where is the left arrow going? Down. So we would say, hey guys, get on board. What would we say for this side? Negative infinity. And then this side, positive infinity. What are you talking about?
I got a really good.
Oh, okay. That's funny. You're funny. It doesn't need to look perfect. Okay, now this one's going to need to be factored. Hey guys, this will be the last one we do today. It's going to need to be factored. So you're going to draw your 2 sets of parentheses. It'll split x times x. And then think about what you would need to get a positive 1x in the middle. Yeah, plus 2 minus 1. Don't cancel until you do the domain. Don't cancel until you do the domain or you'll lose your troublemaker. We have one troublemaker. Who is it? 1 would make this denominator 0. So we want to leave out 1. One can either become a whole or a vertical asymptote. Once you kick him out, those are his 2 like career path options. So is 1 going to be a whole or a vertical asymptote? Good. Vertical asymptote is none because it can't be both. And the whole is 1 comma. How do you get the other part? Plug in 1. All right. So if you plug in 1 to what's left here, 1 plus 2 is 3. So you're going to put a whole at 1, 3. So right there. And again, I recommend doing that immediately. Like as soon as you get something, put it on your graph. All right, horizontal or slant asymptote, compare the powers. This one's squared. This one's to the first. Numerator's bigger. So use synthetic division. What number goes in the little box? 1 is your troublemaker. And you're going to take your coefficients. Your countdown's in order. It's 1, 1, negative 2. And I want you to go ahead and do the synthetic division. And then I want you to tell me what you notice, because you should notice something. There isn't a remainder. Now, we weren't going to use it anyway, but you'll see what happens when there's a zero remainder. It's kind of an interesting thing that turns out. So how do we write this? It's y equals mx plus b. So using those numbers, 1x plus 2. Beautiful. You do not need to put the 1. I just put it to show everyone where that number came from. So that means you're going to start at 2. Here, I'll zoom in. Right here at 2. And you're going to go up 1 over 1. And you should notice something that like kind of bothers you. You should be like, hey, wait, hold on a second. Because what happened? It went through the hole. So hold on, we're going to talk about that. This is kind of an intro. This is sort of like a special case kind of problem. I started at 2. Right there. And then up 1 over 1. Okay, then I'd like to get some points. X-intercepts. Gonna be something 0. You're gonna set this whole thing equal to 0. So what would this give you if you set it equal to 0? -2, good. Now, when you go to put that on the graph, you should be like, hey, wait, hold on a second. Yeah, because it's on the asymptote. And then when you get your y-intercept, when you plug in 0, stick with me. If you plug 0 in for x here, what do you get? 2. 0 plus 2 is 2. And that's also on the asymptote. So when you connect everything, your graph literally is the slant asymptote. You get a line with a hole in it. The reason it was perfect is because the remainder was 0. Very good. Did you do ones last year that were a line with a hole? Oh, yes, no. If you remember, it's fun. So it's a line with a point missing from it. No, it went straight through it. It's like you have, hold on, I want you to understand. Look at this. You have this line and you just like deleted 1 point from it. Yeah, like the asymptote is the line. Like they lined up perfectly because the remainder was 0. It totally can. There's all sorts of weird stuff that can happen. Oh, I threw away my other sticky note, but do you remember I said it can level off here, and go through it in the middle? Like there's all sorts of weird stuff that can happen with rational graphs. Because they're the ends. In the middle it can, but those are the ends. So now it really doesn't matter what order you do the rest of this in. Hey guys, who's your troublemaker for the range? If you sweep downwards to upwards, who gets left out of the range? 3, good. Everybody except 3 is invited to the range party. That's where the hole is, so it's like literally missing. Increasing and decreasing, you read left to right. So what's your graph doing left to right? Good, so decreasing is none. One or the other will be none. And what do you copy over? The domain, because it's left to right. So it has to be X numbers. And then set up your limits for your n. Now it's not leveling off anywhere, so it's going to be either a positive or negative infinity. Where is the left end going? Negative infinity, and then the right end is positive infinity.